So let's go to our compiler.c, and let's go to define a new structure. This new structure called so this new structure is called Upvalue, and what we need to track is the index and some boolean variable. That answer is that Upvalue is local or not. If it is true, that means that it is defined in the direct enclosing compiler, and if it is not, you will need to search up until you found it. So let's add it in our compiler to track that. So what I need to do is add that Upvalues an array for every compiler. As you see in the whiteboard, every closure has its Upvalue table, but in the context of compilation, at compilation time, we have the compiler that stores this table, and the maximum is that. So after the function resolve local, I will add that here. So the function called static int resolve Upvalue, and it will accept the compiler that need to resolve that, and also what's the name of the token that need to be resolved. So first of all, I would check if the compiler enclosing equal null. That means that we are at the top level code, so it means that the variable is not local or is not an Upvalue. It could be a local variable or a global variable. So I need to search in the local variables table for that token. So resolve local. So I will pass the enclosing. So let's assume that we need to search B. So I am in that compiler, so I need to search in the local variable of the enclosing compiler. So that's what I did here, and I will pass the name. So as you see here, I changed the definition of the resolve local. So simply I will add here a pointer to the compiler, and I will change everything here. So compiler, and that's it. So let's continue. So if the local is different than -1, which means I found it in the direct enclosing. So let's go here. So I am searching for B. The B is not in the local variable of the C. So what I need to do, I need to up to its enclosing. So that's what I did here. I resolve the local on the enclosing compiler. So if that enclosing compiler return -1, that means that this variable is in its local array. So what I need to call, I will return add return add app value. We will define this function. I will pass the compiler, and also I will pass the index local, also as if it is local or not. So in that case it's local, so I will return true. So let's define that function here. Static int add app value, and it needs the compiler, also as index, also as boolean variable is local. So we have the something called, so let's do it another time. So let's keep that simple for now. In the case that the local is equal to -1, which means that, so let's see the case of a. So I am resolving the a variable. So what I need to do for the first time, I need to search in the local of its direct enclosing b. So the b will return a value -1, which means that this variable doesn't exist in its local variable. So I need to go recursively until I found that. So what I need to do, I need to set a variable app value called app value on the compiler enclosing. So I go recursively, I will call this function, on that one. So for the first time, our compile point here. So if I didn't found a in this direct enclosing, I will need to run the resolve app value on that compiler. So if it's -1, that exists, mean that it exists in the app one. So I will return add value compiler, and but I will specify that it is not in its indirect enclosing by doing false. And finally I will return -1, and that will go recursively. Don't worry about this function, we'll develop it later. So I will go to object stage, and I will need to update the object function by just adding a app value count. So how many app values of a function? How many app values of a function? So let's assume that C, it has 2 app value. I need to track that it has 2. For this one it has 1 entry, and for this one is 0. So also in the app closure, what we need is to track also that app value count. So we will go to object.c to update that. So here in the function app value count will be 0, and for the closure app value count will be function app value count. So far so good. So let's come back to our compiler.c and let's implement that add app value. So first of all, the app value count is the compiler function app value count. So I need to go entry by entry, and app value count plus plus. So what I need to do is to check if that app value it exists in it exists. So I will add value address compiler. So if is local equal value is local and index is value index. So what I need to return is its index. So that's it. And if it is not exist, what I need to check if a value count reach its maximum. I need to raise an error. Too many closure variables in function. So if all is good, I will add that to the array of the current compiler. Value count index is the index, and also compiler values value count is local and I will return compiler function value count, and I will plus that. So here I check if that one exists or not. So let's go to variable and update that. So for the variable, I will pass the current compiler, and I will check if that's equal. So I will check if the constant is different than -1, which means that is a local variable. I just copy that here. So then I will check else if, and I will get that from the Upvalue from the resolver, and I will pass the current compiler, and the token that needs to be resolved is the parser the previous, and I will check if it is -1. If it is -1, different than -1, that means the up set will be up set Upvalue. We will add this to bytecode, and upget will be upget Upvalue. So else is that it's a global variable. So far so good. So if it is different than -1, it's local. So if I resolve it and I found that that is different than -1, that means that it's an Upvalue. and otherwise will be a global variable. So let's back to our debugger and see how we will so before that I need to go to function and I need to emit these values. So I will do for int I equals 0 less than function value count I plus plus and emit byte compiler dot values I. If it for the is local, if it is true I will emit 1, otherwise I will emit 0, and then I will emit byte compiler dot values I for the index. So that's it, and let's go to our debugger. Here I will read the object function as function from check constants values constants. So I read that value and turn it to a object function, and I will loop over the table of Upvalues value count a plus plus. So int is local. I will take the value and add 1, and then for index the same, and I will also read that on that offset and will add it. So now I will print and we will print that. So -2, that's the offset, and that's the index of number of instruction. Then I will check is local and I will print local, otherwise I will print up value and I will print the index. Printf up here. So that's it for disassembling. So So let's recompile the code and see. And we didn't yet add the objects, the bytecode up get up value and up set up value, and we'll add it right now. So as you see, we don't have these ones, and let's go and add that. Check.h, and we will up get app value and up set app value. So that's it. Let's go to vmcompiler.c. Don't worry about if using body, then compile.c. We need semicolon here. Okay, we need to add that, so let's go to debug.c and add the header of, let's include object h. Okay. So far so good. So what also we need to do is to run don't worry about the runtime. So what I need to do is just to see the bytecode if it is correct, and don't worry about the runtime because we didn't yet implement the how to read app values and how to resolve that in the how to make these app values. We didn't do that in the VM. So I am only now focusing on the compile time, and don't worry about these ones. Worry about only the bytecode. So here you see no instruction because we didn't debug set up values. So we would go to debug.c and let's add that here. So case up get app value, and what we need to do is to return byte instruction on up get app value and chunk offset, and for case offset app value will return byte instruction up set app value and chunk also as offset. So that's it. So let's compile the whole project. So let's get simple and let's see the bytecode. I said don't worry about the runtime because we didn't do much. Okay, so let's see. So as you see, our resolver sees that the closure C has two app values. One is local and the other one is not local. So you see that the B is local and the index is 1, is local and index 1, and for A is not local and the index is 0. So far so good. So let's see for b it should has a up value a. So let's see on the definition of a. As you see, we have for the closure b, I have one local variable at the index 1. So far so good. So what we need to do is to go to our VM to resolve that at runtime and add this structure of object app value, and also I need to VM to track this object app value. So let's go to VM.h, and what I need to do here is to add object app value, open app values. It will track this one. Yes. So also we need to define this structure. So let's go to vm.c and initialize that in the init function, and I will do object vm.open values is not. So let's go to object.h and add that structure. So type def struct, what's name is object app value, and I need that header. Also I need the location on the stack where that app value exists, so I can read its value. That's the whole idea. So also I need some pointer to the next one. Next, you will see later what's the use of that. What we have values, so let's type value. Also inside the object closure I need a table of every app values. So at runtime I need just to read that from it and see what's the value of the app value. So I will update the new closure function, also as I will add a new function that create app value as needed. So new app value and slot. So let's go to object.c for the closure. Okay, object values, I need to allocate an array of these values. So the size of that array is app value count, and I will go to entry by entry inside that, and what I need to do is just to initialize it with none. So app values position is equal to none. So next what I need to do is for the closure app values will be app values. So let's add object app value, and I want the slot the location where it points. The slot is that location, this slot or this slot. So I'll pass it to that function and it does the rest. So value need to allocate that object value value. So for the location value location is the slot, and for the next value is null by default, and I will return that value. So far so good. So let's go to memory.c because we add some new object. So after that I will add object closure, and for that I will read that object closure, and I will free object closure, and I will break. And for the other case object value, I will just free object value So let's add these scopes to avoid some redeclaration of variables. Okay, so let's go to our VM and see how do we construct these when the closure is called. So if we have the call of closure B, so what I need is to build that object value and set that location to point to this. So if the closure C is called, so if the closure A is called, I will set the object value of the B to point to this. So when the closure B is called, I will set the object value of C to point to this and this. And when I need to get to that value, I just to go to that location. So if we have so let's see as an example, if we have a bytecode called object value get value, and the value is the location 0. So I need to read the entry at the 0 location here, and then when I get that object value, I need to read the location and get that value that points on this slot. So we get the idea. And for the set one, I will just get that one and change the value if we have some set operation. So let's go to vm.c and see what we need to do. The two bytecodes, the two simple bytecodes, the up get up value and up set up value. So I will go here, case up get up value. What we need to do is directly we will push the value pointed by the location frame, and I will read the closure, and I will go into its table of up values and I will get the location. But what is the index of that entry? So the index of that entry is the next byte after that byte. The next byte after the byte of get up value, that's the index of the entry inside the table of up values. So I will just call read byte and it will return the index of it, and then I will break. Not yet, for now guys, we didn't fill this up table because I will add it in the closure, but now I will just implement that, and I assume that we did have the up values. And for offset up value, so I will set up values and I will read that byte, and for the location I will set it with the new value, and I will pick it from the top of the stack and I will break. So guys, let's go to this. So when the function a is called, I need to run its bytecode, so I will find that closure, and also I will find these 2 bytes that represent that it's a local, it's a up value variable, so I will need to resolve to capture that up value. So I will add object up value to that closure when the enclosing function is called, and when I need to add these to capture these 2 up values when its closure, the function b, the enclosing function b is called. So when I am here and I found up closure, so that means that its enclosing function is called and it's present on the stack. So we will do something wonderful. I will go, remember that the closure, it has a variable that track the count of up values. So I will go to up value by up value. So let's see this example. I have 2. So this closure, it has a variable that track how many up values it has. So I will read 2 bytes by 2 bytes. So I will read the first byte is local, and I will read it by using the macro read byte. Also I need the index. I will read the byte. So if the is local, which means that, so let's see the example. So I am on the B. I need to define that object up value to point to that. So the function a is called, so I am reading up closure, so the VM read that and also read these 2 bytes. So the VM, it will create it will capture the up value from what? From this one and add the index. So remember guys, the slot that we need is that one. So that one, what is that one? Is the frame, the previous frame, plus an index. So the previous frame, I know what is the previous frame. The previous frame is the slot. The previous is the callee function. So this function, I know that I has a variable that point to it. So I know what is the next local variable of it. So closure Upvalues So what I was saying is I am on this, the VM is running, so it found that this closure, it will run its bytecode, and it sees that we have up closure, and also it sees these two. So the value of that is the frame plus 1. So we have the function, and in the stack you will see that this is the frame, and plus 1, it means that that's the first local variable. If we have plus 2, that's mean that the second local variable. So I will capture that, and this function will return an object Upvalue, and I will give it the index of that Upvalue. So otherwise, what it means that I need to just point on the frame closure Upvalues at that index. In this case is the case of the C. So we have a variable A, and the variable A is previously resolved by the B. So what I need to do is just point to its direct enclosure closure function. So it will just point to that, and from that I will get that. So let's implement that function. So let's go here and static object Upvalue capture Upvalue value and local, or you can name it location, local, whatever. So I will remember, guys, that I said that we have a VM that track these objects. So if we have some duplicate, I need just to go through this linked list, and if I see one, I will not define a new one. So objects Upvalue it's on Upvalue VM open Upvalues. So I will go through this linked list Upvalue to see where I need to put it, this new Upvalue. So I will run over until I found the location to be greater than this one, this local. So I will update the previous one to be Upvalue, and the Upvalue, it will be Upvalue next. So guys, I am adding this object Upvalue to this linked list by by the greatest address. This one is the greater address from that one. This address is greater than this address. So the greater address, it will be directly pointed by the VM, and so on, by from high to low addresses. So that's why I did up value location. If that up value location is greater than local, so I didn't find the right place. So if I have an address that is smaller than one, I will start from here. So I will see that this location is smaller than one, so I will go. I found the exact location, and so I need to light the bigger one at first. So that means I found the location, so I will check if the up value is different than null, and up value location is equal to that local, which means it is on the linked list. So what I need to do is return that up value, and the example of this one, this is the variable a, it point to that one. So this is not included in the chain, in the linked list. So it just be there. I just return this one. So this one is exact as this one. I would not add it in the linked list. It's the duplicate. So I will continue, and I will create an up value. So remember, this function state will return up values, and I will pass the location of that. So created up value next will be the last one I point to it, because I update this up value to the next one, and so I found the exact location. So the next will be not null, but it will be this one, this up value. So I will check something. If the prev up value is equal to null, which means that the VM open up values, it will point it to the created up value, because that case means that this up value is the greatest location, so it should be there. So the VM needs to point to it and then do the rest. So otherwise, the previous one, previous value next, it will point to the created up value. Simple procedures just to add the exact structure inside the linked list. So far so good. So that will do the job. So yeah. So let's clean and rebuild the project and see if we have any objects of value. So then memory.c, and I will do a break. So let's make all that. So in object.c, it's objects of value. So then object.c so then vm.c, and let's go to capture function, and these, they are pointers, not simple variables. So we have value location in let's see. And for that one, okay, and let's see, the table have values. So guys, it's good. So let's get sample and let's see if we have done everything is good. So as you see in the C, we have up value 0 and get the up value 0. For the closure B, closure C, it has 2 values, and for the closure A, closure B, it has 1 local variable. So let's see what's the when we call the P function, what it prints. So if we call the P function is here, and what it does, we will load 2, and this is the local variable B of the function B, and we have get up value 0, and as you see, I've loaded to the stack 1, and that's good. I've loaded 1. So when I load this one, I print 1. So let's see when we call the closure C. So we have the closure C, and when the call is happen is here. So as you see, we will call this one. So I will get the up value 0 is 2. 2 is the up value B. So far so good, and we will print it. So for the up value 1, also I will load 1, and then I'll print it. When the function is finished, it will load null, and it will return that. Also the function B, it will return null, and we'll have null, and we are on the A function, and the A function also, it will return null, and we are here on the script function. So far so good. So let's go to common.h and deactivate these macros for debugging to see the real program. So make clean, make all, and let's cut that one, and let's rerun our interpreter. So as you see, we've printed A1, and also we printed 2 and 1. So let's see for the set. I will here set the up value to be 100, and as you see here, it will print 100, and also here it will be print 100. Okay, sample things. So as you see, we call A, and A we call B, and when we call B, it will print 1, and then it set the up value 100, and when we call the C, we will print B, and the value of B is 2, and the value of A is changed to be 100, and it print 100, and here we print 100. Okay, so now I will introduce another bug that we need to fix. So let's see that let's say that we have a function called outer, and inside that function I will just copy that from here. Okay, var a has 2 and function inner it has need to print null and print a. Normally that it's an up value, so it should print the output should be 2. It should be. And what I need to do is to set that up value to be 5, and I will return the function, the inner function. So for the call, I just call the outer, and the outer will return the inner function, and then I will call the inner function. So let's see what will happen. And let's run our interpreter. Okay. Okay. So this function should be, when we return that, the function should print, because that it's an inner function, it should remember the state of its up values, so it should return null, and it should print here 5, not 2, because I changed that. So as you see, guys, when we call the function is here. So as you see, when we call the inner function, calling the inner function, we print nil, and also we print nil 2 times. So get up value is nil. So what is happening here? The real problem, guys, here in up values is that we are pointing to a location on the stack. So the objects, the up value of the closure inner it points to this location, and this location is changed by nil. It doesn't have the previous value 5, so it will print nil. So as you see here, guys, this is the stack, and we have the outer, and the outer function it has as a local 2, and the closure inner it point to that one. So when we call the closure inner and return that function, so the value on the stack is not 2, it's 5, because we assign that 5. So the closure inner it has an object up value that point on that address, but that address is changed when we load nil to the stack. So the previous value is 5, and when we load, so the object up value it points to that address and it's correct, but when we load to stack the value nil, it changed that location, so we will get an incorrect value of variable a. So what we need to do, the solution is to add another variable called closed. So when the return it will happen, what we need to do is to close that up value, to close it, and the location it will not point to this location, it will point to the closed variable that hold the previous variable 2 at this example. So that's it, guys. This is the solution. We will add another variable called closed, and when the return happen in every function, we will close every up value that is greater than this location. So let's assume that we need to close that, to close this. So the location is this. Let's assume that the location is, I need to close every location that is in address greater than this one. So I will implement a function that I will pass it this location of that closure, and it goes to the linked list of all objects of value, and I will close every object of value that is greater than this location. So let's go and implement that. So vim objects.c .h objects of value, I will add a value called closed. So let's go to object.c, and inside objects of value for the app value close will be nil var. Okay, excuse me. So let's go to the VM, guys. We will go to operator, and the closing routine will happen at each return on a function. So I will call function on called close up values on the frame slots. So the frame slots, it point to the closure on the stack, and I will close every up value that is greater than this location. So let's add that function. So static void close up value, and the last value in the stack. So in this example, the last one is that. So when we have a return, so this is the address that I need to compare with the app value to be closed. So I will pass to the close value function this location, and I will search from the VM, and I will search for every location. So let's see, this location, it points to this address, and when I did pop, when I did the return, the object inner is here. So that address is smaller than this one. So the VM, it track this address. So I will go on the VM, and I will see every location that is greater. So for this example is at a1 is greater than this one, so I need to close this object's app value. So while VM open app values different than null, and the VM open app values location is greater or equal than last. So what we will need to do is say objects app value VM dot open app values, and app value closed will be the app value location, just the value of that location, and then the app value location will be pointing to app value closed, and then VM dot open app value, I will change its place to point to the next one. So that's it, it's easy. So by that we solved the problem, hopefully solving the problem. So mvn.c so here we have open Upvalues. So let's clear that, so we have all is good. So let's get that sample and let's see. So as you see we have nil and 5, so the inner function is closed on the previous Upvalue. So we solved the problem. So as you see here we don't have nil and nil because after the return happened. So when the return happen of the function over here, so when the return happen, this closure will close its Upvalue, so it will not point on that, but it will point on an Upvalue that is closed. So when I do get Upvalue, it will has that 5. So let's comment this debugging macros. Okay. So as you see, nil and 5. So we've implemented the closure concept that remember the state of its Upvalues, the state of the variable that is declared in. And also what I need to do is to enhance the runtime error. So I need to print the whole call stack. So let's see that. Let's have an error here. Let's assume that we print a variable that does not exist. So let's see what the error will be. So as you see, undefined variable C. So I need that this error will be enhanced by saying that what is the call stack from the script and in the function f and in the function inner, that's the error. So let's go to vm.c and let's go to runtime error. So where is runtime error? Yes, here. So I have the frame count, how many function is called, and I will go until the final one, minus. I will get the frame. Also I will get the function, the frame closure function. Also I need this variable here. Also I need this printing here. So we'll remove this one. So function, and here also function. So if function name is equal null, I will printf that is else I will print the name of the callee function and shows. Okay, and I will reset stack. So the reset stack is just a function, static void reset stack. What it does, it just reset these variables. And I will call reset stack here. And that's it. So we print all the stack, the call stacks. So that's it. That's it. Okay, so let's see. So let's rebuild the project and see. So let's run the end interpreter. So as you see, we have the error on. So let's add one more update. Just see that I will do line in let's rerun that. So as you see that on the line 16 in the function script, so the top level code, so this is the line 16, 1 2 3 4 5. So in the line 16 on the script we have the call, and this is the 16, line 16, we have the call outro. So in the line 6, 1 2, in the variable inner 1 2 3 4 5 6, so this is the line, and the error is undefined variable. So that's good for the runtime error. We enhanced that just to see the call stack, and you can as a developer see where is that error comes from, from which functions that error comes from, and that is good from the script to the inner and the error is. So guys, we've reached the end of the video. So in this session we treated the closures function, that remember it's variables, it remembers the environment where it is declared. And also we introduced the concept of Upvalues, and we treat that, and we close the Upvalues when we have return. So guys, we've accomplished something good in functions, and our int language is capable now to create and call functions and do whatever you want with function. So see you guys in another session, and we'll treat the native functions, or called the foreign functions. This native function, it will extend our language with functions that predefined so that the user can use. So see you guys in another session.